Space is vast, really truly vast. When we look up at the night sky we see stars, lots of stars, but what we're seeing is just a tiny fraction of what's out there. Our galaxy, the Milky Way, is just one of billions upon billions of galaxies in the observable universe. And these galaxies aren't just sitting still, they're moving, they're dancing to a cosmic tune orchestrated by gravity. But here's the thing, something strange is happening, something is pulling on our galaxy and countless others with an immense gravitational force. We call it the Great Attractor. It's a mysterious region of space that lies hidden behind the plane of our own galaxy. We can't see it directly with optical telescopes, but we know it's there. The way galaxies are moving tells us so. Think of it like a cosmic magnet drawing everything towards it. But unlike a magnet, the Great Attractor isn't just one thing. It's a massive concentration of matter, a gravitational anomaly that has captivated astronomers for decades. The Great Attractor is a gravitational anomaly. It's a region of space that exerts a strong gravitational pull on our galaxy and millions of others. It was first discovered in the 1970s when astronomers noticed something peculiar. Galaxies, including our own Milky Way, were moving towards a specific point in space. This point, located roughly 250 million light-years away, became known as the Great Attractor. It's like a cosmic valley, and we're all sliding down its slopes. But what exactly is causing this massive gravitational pull? That's the million-dollar question, or perhaps billion-dollar question, given the cosmic scales involved. Initially, astronomers thought it might be a single supermassive object like a gigantic black hole. But further observations revealed a more complex picture. The Great Attractor isn't just one thing, it's a massive concentration of galaxy clusters. These clusters, each containing hundreds or even thousands of galaxies, are clumped together in a region of space known as the Laniakea supercluster. The combined gravitational pull of all these galaxies creates the force we observe. Observing the Great Attractor directly is like trying to see through a wall. It lies behind the plane of our galaxy, obscured by gas, dust, and stars. This region, known as the Zone of Avoidance, makes it difficult for us to get a clear view of what's happening on the other side. Imagine trying to see a distant mountain range through a dense forest. The trees block your view, making it hard to make out the details of the mountains beyond. That's the challenge astronomers face when studying the Great Attractor. But just as there are ways to see through forests, like climbing a tall tree or using radar, astronomers have developed tools to peer through the Zone of Avoidance. X-ray and radio telescopes, for example, can detect radiation that penetrates through gas and dust, allowing us to glimpse the hidden universe beyond. These advanced telescopes have revealed a wealth of information about the Great Attractor. We've discovered massive galaxy clusters, supermassive black holes, and vast clouds of hot gas, all contributing to the gravitational pull that influences our cosmic neighborhood. X-ray and radio telescopes have become essential tools for astronomers studying the Great Attractor. These instruments detect radiation that's invisible to the human eye, allowing us to see through the veil of gas and dust that obscures our view. X-ray telescopes, like NASA's Chandra X-ray Observatory, detect high-energy radiation emitted by hot gas and supermassive black holes. These observations have revealed the presence of massive galaxy clusters within the Great Attractor, each teeming with hundreds or thousands of galaxies. Radio telescopes, on the other hand, detect radio waves emitted by objects in space. These waves can penetrate through gas and dust even better than X-rays, providing us with a clearer picture of the structure and dynamics of the Great Attractor. One notable example is the Parkes Observatory in Australia, which played a crucial role in mapping the distribution of galaxies in the Zone of Avoidance. By combining observations from X-ray and radio telescopes, astronomers have been able to piece together a more complete picture of the Great Attractor and its influence on the surrounding galaxies. Section 5. The pull of the cosmos, gravitational forces explained. Gravity. It's the force that holds us to the Earth. keeps the moon in orbit around our planet, and governs the motion of stars and galaxies throughout the universe. But how does it work? Imagine a bowling ball placed on a trampoline. The ball creates a dip in the trampoline's surface. Now roll a marble across the trampoline. What happens? The marble's path curves as it approaches the bowling ball, even if it doesn't hit it directly. That's because the bowling ball has warped the trampoline's surface, creating a gravitational well. The same principle applies to the Great Attractor. The massive concentration of galaxies in this region creates a gravitational well that influences the motion of galaxies for hundreds of millions of light-years around. The greater the mass of an object, the stronger its gravitational pull. The Great Attractor, with its trillions upon trillions of stars, exerts a powerful force on our galaxy and countless others, drawing them towards it like moths to a cosmic flame. Section 6. Galactic Giants comparing the Great Attractor and other phenomena. The Great Attractor is a cosmic heavyweight, but it's not alone in the universe. There are other massive structures out there, each with its own gravitational influence. Galaxy clusters, for example, are collections of hundreds or even thousands of galaxies bound together by gravity. These clusters are like cosmic cities, bustling with galactic activity. Superclusters, on the other hand, are even larger structures composed of multiple galaxy clusters. They're like cosmic metropolises, spanning hundreds of millions of light-years. The Great Attractor is thought to be part of a supercluster known as Laniakea. But there are even larger structures out there like the Hercules Corona Borealis Great Wall, a vast filament of galaxies that stretches for billions of light-years. These cosmic behemoths are a testament to the immense scale and complexity of the universe. And then there are black holes, the ultimate gravitational traps. These objects are so dense that nothing, not even light, can escape their gravitational pull. While black holes don't play a significant role in the Great Attractor's gravitational influence, they are fascinating objects in their own right, warping space-time and influencing the evolution of galaxies. Section 7. The Shapley Supercluster, a cosmic web of influence. As astronomers delve deeper into the mysteries of the Great Attractor, they've uncovered a potentially even grander structure influencing its behavior: the Shapley Supercluster. Located about 650 million light-years away, Shapley is a colossal concentration of mass, harboring thousands of galaxies and boasting a gravitational pull that dwarfs even the Great Attractor. Imagine a complex web, with strands of silk connecting distant points. In this cosmic analogy, the Shapley Supercluster acts as a massive hub, its gravity pulling on the surrounding cosmic web and influencing the motion of galaxy clusters, including those within the Great Attractor. This discovery has led to a fascinating realization. The Great Attractor might not be the ultimate gravitational force in our cosmic neighborhood. Instead, it could be a mere puppet, its movements dictated by the unseen hand of the more distant and powerful Shapley Supercluster. This revelation underscores the interconnected nature of the universe, where gravity acts across vast distances, connecting seemingly disparate regions of space in a delicate cosmic dance. Section 8. A Journey to the Great Attractor. The Great Attractor calls to us like a siren song, beckoning us to explore its depths and unravel its mysteries. But here's the catch. Even if we could travel at the speed of light, it would take us hundreds of millions of years to reach it. And that's just one way. The universe is expanding, and the space between galaxies is stretching. This expansion is accelerating, driven by a mysterious force known as dark energy. The farther away an object is, the faster it's moving away from us. So even if we set off on a journey to the Great Attractor today, the expansion of the universe would constantly be increasing the distance between us. It's like trying to run on a treadmill that's constantly speeding up. We'd never quite reach our destination. But fear not, intrepid explorers. While a physical journey to the Great Attractor might be impractical, there's nothing stopping us from exploring it from afar. With ever more powerful telescopes and sophisticated computer simulations, we can continue to study this enigmatic region of space and unlock its secrets. Section 9. The Unfolding Cosmos, Unresolved Mysteries and Future Explorations. The Great Attractor, once a mysterious anomaly, is slowly revealing its secrets. We've learned that it's not a single object, but a massive concentration of galaxies, part of the vast cosmic web that connects the universe. We've peered through the Zone of Avoidance using X-ray and radio telescopes, uncovering hidden clusters and superclusters that contribute to its gravitational pull. But like any good mystery, the more we learn, the more questions arise. What is the precise distribution of matter within the Great Attractor? How did it form, and how has it evolved over billions of years? And what role does dark matter, this elusive substance that makes up the majority of the universe's mass, play in its dynamics? These are just a few of the questions that keep astronomers up at night, their curiosity fueled by the endless wonders of the cosmos. The Great Attractor serves as a reminder that the universe is full of surprises, and there's always something new to discover. So the next time you look up at the night sky, remember the invisible forces at play, shaping the destiny of galaxies across vast distances. The universe is a tapestry of wonder, and the Great Attractor is just one of its many breathtaking threads.